morning, class. Today we are going to start our study of physics in Science 10. This is exciting, a new chapter. Now, physics, it's the study of all things. We're trying to find and use the rules that are universal, which means we want to apply it to literally everything in the universe. We want a rule to describe everything. Now, you might think that there are a ton of differences between things throughout everything in the universe, but there's something that's always the same. And the way things move are always the same. We can describe them in the same way. So physics truly begins with understanding motion and how we can describe things moving. So let's get started talking about some of the vocabulary and ideas that we're going to use in our physics chapter. The first thing that we're going to discuss are scalars versus vectors. Now, a scalar is any measurable quantity that includes the magnitude. And magnitude is just a fancy science word that means size. A vector, on the other hand, is a measurable value that includes the magnitude, the size, and the direction. And we normally represent vectors as an arrow, because an arrow can be different sizes, and arrows inherently show direction. Now, it's important to understand the difference between scalars and vectors is because we can use some things that are scalars and that tells us certain information, but there are going to be other times when using scalars, by not including direction, we're actually going to be leaving out information, leaving us in the dark. And that's when vectors are going to be more important. There are some values that cannot be measured as vectors, however. Things such as mass, right? Your mass doesn't have any direction, it just exists. Let's talk about our first two key terms in motion. First one is distance. Distance is just the total length that something is going to travel over some time period. How far did that go? That's a distance question. Displacement has a bit more of a particular definition. The displacement is the total change in position that something travels over a time period. So if you want to know the change of position, you're actually going to measure from where the object starts and where the object ends. Anything else in between doesn't really matter. All you care about is where it changed from start to end. So let's take a look at an example. And you know what? I'm going to start by drawing it out, and then we can figure things out from there. Jerry, he walks 5 meters to the right, and then chooses to walk 12 meters to the left. Well, if I'm looking at this situation, what distance did Jerry walk? Well, Jerry walked 5 meters and then 12 meters. Distance is my total length, so I would just take my 5 meters and my 12 meters, and that means he walked a total of 17 meters. What's really important that I include in my answer is important that I include the units, right? If I just said he walked 17, I wouldn't know 17 of what? Maybe he could have walked 17 kilometers. That'd be very different. Now let's take a moment and analyze, what is Jerry's displacement? So displacement has the definition of change in position, and you compare it from where it starts to where it ends. So this is where Jerry started. This is where Jerry ended. Doing a little bit of analysis, his displacement is going to be this bit that I have here in red. Or we see that that bit should be 7 meters long, because that's the difference between our 5 meter and our 12 meter motion. So we'd say, okay, Jerry's displacement is 7 meters. However, displacement is a vector. And so that means we also need to include the direction. Which way does that end up? That ends up 7 meters to the left. So our key here is the distance is a scalar value. We can include just how big it is, but our displacement is our vector value. We always need to include how big and which direction. Let's talk about our other pair of values that are very related, speed and velocity. Speed is the rate of change of distance. And you can calculate the speed by taking whatever distance something has traveled and divide it by how much time it took to travel there. Since speed is related to distance and distance is a scalar, speed is also a scalar. So if you describe something in terms of how fast it's going, but you don't tell me where it's going, you're telling me its speed. Velocity is described as the rate of change of displacement. And the way that you can calculate your velocity is that you can take your quantity of displacement and divide that by the amount of time that it's taking. And since velocity relies on displacement, which is a vector, velocity is our vector. So let's take a look at this new situation and see what's happening. Jerry is going to walk 30 meters north and then 10 meters south. Now Jerry's going to take 80 seconds to complete this walk. What's Jerry's speed for this walk? Well, on average, we would be able to find out his speed by taking his total distance and dividing by the time. So what distance did Jerry walk? Well, he walked 30 north and then 10 south. That's a total of 40 meters. And how much time did he took? He took 80 seconds. Now, if you grab out your calculators and you punch in 40 divided by 80, that is 1/2, or 0.5. Now, one thing that I did is I included my units in my calculation, my meters and my seconds. This is actually a hint because this gives you the units. I have meters over seconds. Meters per second is how we call it. So if you include your units in your calculation, you'll actually be able to see what unit is the result. What about Jerry's velocity? We know that we can calculate the velocity by taking the displacement over the time. And remember, we find our displacement by comparing where we started to comparing where we ended. Or we see here, oh, this would be a total of 20 meters, but it's also heading in the north direction. So our displacement is 20 meters over our total amount of time, our 80 seconds. And if you put that into your calculator, that'd be 1/4 or 0.25 meters per second. Now our answer isn't done until we include the direction because velocity is a vector. So it is 0.25 meters per second. In total, ended up moving north. That's it for today. Have yourselves a good day, everybody.